we're going to take a look at a few things in here and start to build out a spark timing table. Pretty basic and pretty simple. We'll find similar to the idea of working within our main volumetric efficiency table. We have our breakpoints to figure out what we want to run, and then the values in the actual table. So looking at this, looking at our axes, this is going to be in map KPA. This is going from 0 KPA to 100, that's our vacuum area here, and then from 100 up to 240 kPa. This would be positive manifold pressure. If you're naturally aspirated, you don't need to go higher than 100 kPa, and in that case, I would build out your breakpoints in 10 kPa jumps and loads, so 0, 10, 20, 30, 40, on and on. In this case, I'm not going to go higher than about 160, 180 kPa with this particular pulley that's on this supercharger. So we're going to go in here, I'm going to reconfigure this real quick. We're going to click X, and we're going to go down here, and I'm going to get rid of some data points. We're going to go and get rid of 240, and we're going to get rid of 220, and we're going to get rid of 200. And then we're going to find here that we have our RPM breakpoints. We don't need one here at 750. That's going to be fine. We can get rid of that. And going out here, we definitely don't need to have breakpoints going out to 10,000 or 9,500 or even 9,000. Will be sufficient going out to 85. Now, the reason why I'm doing this, and I'm shrinking down the resolution and not caring a whole lot about the resolution for RPM here in the table, because this represents low cam. We can have two spark timing tables, one for low and one for high. In this case, we're building this out for low cam operation, just like we were in the main fuel table. So we have low and high cam, the way I'm going to be setting this up. You don't have to do this, but this is the best way to represent a VTEC engine, a Honda engine. So we've built out the table. Now we need to take a look at the values within the table and see if they're going to be valid. First thing we want to do here is take a look at our idle area here, 0 to about 60 kPa. Let's go here from 0 to about 1500 RPM. We're going to set our values here at 15 degrees. Now we're going to have separate spark timing for idle conditions. We want to have something here if we drive off idle to have a reasonable spark timing amount. So 15 is good there. At 180, 0 to 1500, we're going to say 0 degrees. And then between these points here, between 60 to 180, we'll do Shift V, and we'll just do a vertical interpolation. We're going to be pulling timing out as our load goes up. Now, what we're going to do here, we can see the tables going from 15 degrees and part throttle, so we're really looking at 100 kPa and below right now. We're focusing on this area right here. Looking at the values in the table, they're going to be running about 40 to 45 degrees. Now, what we're going to do is actually set this table all to 15 degrees. We're actually going to copy this 1500 RPM point, and we're just going to copy it throughout the rest of the table. Now, we're doing this specifically so that when we're doing our fuel tuning, we don't have to worry about knocker pre-ignition occurring. We can come back in and actually evaluate optimizing the spark timing at a later portion in the calibration process. But by having our timing values low here, we can drive the car, we can get our fuel sorted out, then we can deal with our spark timing. We always want to move in that order of operations. We don't want to go in and tune our spark timing and then our fuel. We want to tune our fuel and then our spark timing. So I'm setting the table up conservatively. We'll go back in and we'll learn how we can build this table out and making sure that we are accounting for having the proper spark timing. This is lower spark timing that we want to run, but that's okay again. That'll get us going, at least get things started with our base map. Now we do have a few other things here. We have an intake air temp ignition trim table. This is useful because if we get too hot of air temperature, we'll find the air density is going to go down and the engine is more likely to knock or pre-ignite, which we want to avoid. Taking a look at this table is already pre-populated, so from negative 22 to 86 degrees, it's zeroed out. That's fine. Once we start to get above 86 degrees, so 104, 122, we can see the timing here is progressively retarded. I'm not going to have the retarded amount going so aggressive. I'll say maybe -6 is the most I'm going to take out, and then I'm going to start 100 degrees. We'll start it at 0, and between these two, between 100 to 200, I will do Shift H. It'll start to take that timing out. Now, if we need more ignition retard, if we're noticing we have knock behavior as the air temperature gets really hot, we can always come back in here and change the values. I don't like to have overly aggressive values to get things going with, because if I'm doing my full throttle tuning, I'm already going to have very low conservative spark timing value in the table, so I'm not worried about damaging the engine. All right. We do have an ECT comp table. What I want to turn on right now, I actually want to bring that in here because we usually want to have a little bit more spark timing when the engine is cold and warming up. This allows a little bit of that lost torque that we lose to be able to compensate it for. So when the wall wetting is poor, we've talked about that, the injector atomization is poor, we need to have a little bit more fuel at it a little bit more torque in order to make the engine run smooth. We can get torque based on either more airflow, more spark timing, or richening up the mixture. So we've already accounted for richening up the mixture with our warm-up enrichment table and our lambda target table compensation, that lambda overlay table. we're going to work with this in the spark timing. So if I go here, we see this is a two-dimensional value. What I'm going to have to do is actually bring this in here into our parameters. I'm going to jump into our ignition, not into parameters, I'm sorry, into our ECU settings, ignition corrections, and our ECT, and we have our table here. Let's unlock this. Let's populate this out here. I'm actually going to change this. Let's change this to a three-dimensional table, not a two-dimensional, because we do want this to be three-dimensional. I'll talk about this, talk about why here real quick. So this is going to be the three-dimensional table now. MGP on one axis. We have our coolant temp on the other. Coolant temp on the other. What we're going to do here is go X, and we're going to get rid of some of these data points. I don't need as many data points. We'll start at 32.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.